Good morning. Here's what we're going to work on now. This is the rest of this unit. All right, we're going to move along with triangle congruency, ideas of triangle congruency, and now this is going to be our focus for the rest of the unit. Okay, you can prove two triangles are congruent. We're going to set up today the concepts of the first of 5 things we can use to prove triangles are congruent. Okay, we're going to go over those today. And then we're not going to start a 2-column proof, but we are going to set up those ideas of how to find information based off of the clues that they give us, okay? And then today our focus is going to be on these 2 bits of information, side, 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 and side, angle, side, okay? But before we do that, let's just go through really quick. I want you to name this angle in 3 ways. Okay, remember how to do that? Go ahead and do it. One is angle B, okay? Since it's a single angle, we can do that. We got angle ABC or angle CBA, all right? So either starting here and following along or starting at C and following along, where B is the vertex, that middle letter is the vertex of our triangle, okay? Or of our angle, sorry. The reason why we want to do that is because we're going to be given pictures like this today. We have to understand and know what angles they're talking about when they say given angle CAD or something like that. So go ahead, highlight angle CAD. Okay, same idea. Start at the first letter, highlight up to the second letter, down to the third letter. All right, that's angle CAD. All right, here are all the clues that we can give you, okay? The reflexive side, remember the reflexive property said angle A is congruent to angle A, all right? Something is congruent to itself. So right here, we have 2 triangles. If we split it apart and we name the 2 triangles SPR, and then we name the other triangle QPR, you would notice that they have the same 2 letters in common. They have this PR in common because it's on both sides. That is what we call the reflexive side. All right, what we know about that then, and the information we can say about that is PR is congruent to PR. That's a statement we are going to use, and the reasoning behind it is going to be the reflexive property. So anytime those triangles are smushed together and they share the side both triangles have in common, the ones that they share, that is the reflexive side. Okay? How about this one? Go ahead, highlight the reflexive side, and then write. This is where we got to be careful. Now we got to match up, going through what we talked about, congruent sides. If we were going to write the congruency statement, what angles goes with what angles? So I would start with, first off, the reflexive side is this guy right here. Okay? Now, E of this triangle goes with G of this triangle. Okay, that's easy to see. E and G go together. Okay? And then I'm going to go down the one with 2 tick marks. So E to F is the same as going G to H. Okay, E to F, same as G to H, and then this is going to be H, and this is going to be F. Now the difference here is we have the same 2 letters, and we share that common side. However, when we match up congruent parts with congruent parts like we did last week, we see that FH goes with HF. Okay, that's important to make sure we have order matters, because when we get into our proofs and we're trying to prove angles are congruent, H of one triangle is not equal to the H of the other triangle. In this case, H and F are going to be congruent from one triangle to the next. So you have to be careful. And that's why we were stressing last week that order is going to matter. Right? Here we didn't have to worry about that because angle P was congruent to itself because of the congruent marks. Angle R was congruent to itself because they were the 90-degree angles. S and Q were equal to each other. So when we write it in order, P was congruent with P, R was congruent with R, so that's why we didn't have to switch orders on this first one. So you have to be careful on how things are drawn. Okay, that's reflexive property of the reflexive side. So that's a clue. Anytime the triangles are put together like that, reflexive property, we got to start thinking and seeing that right away. All right, next one we got vertical angles. Look for the two crossing lines or segments, okay? So highlight the two segments that are crossing. Looks like this. All right, well, what angles are vertical? This angle here and this angle here are going to be automatically congruent because they're vertical angles, right? Now we have to make sure we label it right. So V and Z go together, right? So I'm just, again, writing a small congruency statement or thinking about writing the congruency statement. Well, those two angles in the middle are equal. And that means W is congruent to Y. So when I'm writing this out, I can't say angle X is congruent to angle X because I don't know, are you talking this angle X, this angle X, this angle X, or this angle X? So that's why we went through and made sure we knew how to label an angle. VXY is congruent to, angle ZXY. So VXW congruent to ZXY. Okay? Same thing over here. Anytime we have these two lines cross, we have vertical angles. So this angle and this angle are automatically congruent. Now we have to start with the one, I look at the tick marks then, okay? Now D to E is the same as A to E. So I'm going to put D, E, B is congruent to angle AEC. Okay? You could have switched it around and said angle BED is congruent to angle CEA if you wanted to, right? Both of those would be the same, saying the same angle. But again, the way it's drawn, they're not symmetric, cut straight down the middle. It's the same on both sides. And the first one it is, and the second one, it is not. They're kind of like twisted around. So you have to be careful on how you are naming everything. Order matters, right? Order matters. Midpoint. Definition of midpoint means it's smack dab in the middle, meaning I have two congruent pieces. So when they say E is the midpoint of KW, all right, so KW is down here. What does that mean to be the midpoint? It means the distance from K to E is the same distance as W to K. So what information can I write off of this information? Because they give me the midpoint, I can say the distance from K to E is congruent to WE. Why? That's what it means to be a midpoint, definition of midpoint, okay? You try this one. Again, order matters, so think about how the triangles are drawn. D is the midpoint of MT, so I know those two sides are congruent. I write MD is congruent to, now look at how the triangle is drawn. This point right here is the same as this point right here. So I have to put MD is congruent to TD. Oh, sorry, whoops. I just mixed myself up. Wrong. M goes with D of this triangle, so DT. Again, you have to be careful on things are drawn. All right, angle bisector. Splits an angle in half, forms two congruent angles, and this is where, again, we have to understand what it's saying. AD is the angle bisector of BAC. So BAC gets split in half. Phone's ringing, I'm going to have to call him back. Okay? BAC, so what does that mean? It means this angle here is congruent to this angle here. So what information is that? Angle BAD is congruent to angle CAD. All right, DC bisects ACB. So again, ACB is the one getting bisected. That means this angle here and this angle here are congruent. Since they have numbers, I can do angle 1 is congruent to angle 2. If they didn't give me the numbers, then I would have to say angle ACD is congruent to angle BCD. Angle bisector, we could split angles in half, okay? Now, how does this all tie in together? If I gave you 3 sticks and said, all right, here you go, make triangles, guess what? Everyone's going to have the same stinking triangle. They're only going to fit together one way, and everybody's way is going to be the same. So we have this property, side, side, side congruency statement. Right? The condition is if 3 sides of one triangle are congruent to 3 sides of another triangle, then what? So we have an if-then statement. We've been working on them. If that's true, then the 2 triangles are congruent. So they're going to give us some information, right? Thinking down the road here, they're going to give us information. And then if we can show 3 sides of one triangle are congruent to 3 sides of another triangle, you can say those 2 triangles are congruent. And that's going to be our goal. So what we're doing is we're making a list of 5 things. Side, side, side is the first one. That's the second one. We're going to go over those 2 today. Angle, angle, side, angle, and one we call HL. And we'll get to HL, don't worry about that. Okay? What do you think the A stands for, by the way? Angle, right? So order matters. When we're writing this out, side, angle, side, order matters. Right? You'll figure it out. Side, side, angle, or the butt theorem as I like to call it, you'll figure that one out. That's not in the same order as any of those 4 up there. So when we're doing this, we have to stay in order. Okay? We have to stay in order. So in order to prove these 2 triangles are congruent, we got to have tick marks all over the place or information given to us that's going to help us out. Okay, if I could show 3 sides of one to 3 sides of the other, then I can write a congruency statement and say that the 2 triangles are congruent. Okay, given 2 sides and the angle in between, we call this the included angle. So if I gave you and said set up and draw me a triangle, here are your 2 side lengths. They are connected just like that. The only way to finish that triangle is to draw this right here. Guess what? Everybody's triangle is going to be 100% identical. So what we're going to do is if we can prove that this side, this angle, and this side are congruent to that side, that angle, and another side smushed together like that, then we are congruent. We call that side angle side. So if 2 sides in the included angle of one triangle is congruent to 2 sides in the included angle of another triangle, then the 2 are congruent. So again, that information, a side angle side, is if you just drew a triangle. Draw an angle. That's the information we need for side angle side. Side, angle, side. Okay? A lot of different ways to do this, but if I said side, angle, side, this would be the side. What angle is the included angle right now? So B to C to A. Angle C is the included angle. Same thing, if I switched up the sides, so if I could show that is congruent to that, guess what? Triangles are congruent. The included angle is not D or E, right? It's got to be the one down here. Has to go in that order, right? Like I said, side, side angle. Or why do I call that the butt theorem? Anyone figure that out? Why don't you flip it around? That's why we call it the butt theorem, right? That is not good, okay? Has to be side angle side. All right, so are the two triangles congruent, yes or no? All right, so, and why not? So when we're going through this, we have two that we know right now. Now, if I think it's side, 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 right now we have, hey, congruent, congruent, that's good. Congruent, congruent, that's good. It doesn't give us any other information about this. So things we would look for. Are the sides connected? Can we use that reflexive property? Does it say anything about midpoints, anything like that? No, these are two separated triangles. I'm not going to be able to say anything about that. However, they give me a congruent angle. So is that angle the included angle in the middle? Again, there's side, angles in the middle, side. Yes. Side, angle, side. Okay? How about these guys? What about this one? Highlight the information. We got a side. We got another side. I'll do it in a different color here. We got another side. They don't have any angles, don't have anything like that. But we do have that one that we talked about right here in the middle. Okay? Because they share the same side. Well, no, that's just going to be the one because the other ones. So we'll just say that's one here. Okay? What property let us know that? That's the reflexive property to say that green side is congruent to the green side. All right? So this is going to be yes, side, side, side. Okay? Let's do this one. Here's a side. Here's an angle. And then do we have another side congruent here? And the answer is yes. The one straight down the middle. Okay, the one straight down the middle. However, because again, that's reflexive property. However, is this side angle side? Is this side angle side? And the answer is no.
This is Thomas. Patty Thomas. Will you dial 3702, please?
That angle is not the included angle. That angle that they gave us congruent has to be down here where the green and the blue are meeting, right? And that's not the case. So side angle side, not good. So that is no good, right? So use side, side, side to explain. So it's telling us that there's a third side congruent. How do I know that? What property? Reflexive. Okay, we could see that this two, we would set up a 2-column proof. They already gave us two sides. The third side's congruent because of the reflexive property. Dunsky. Side angle side. Okay, how do I know? Well, side, included angle, reflexive property again. So you could say that in words, write that down. Well, they gave us the side and angle, and then WY is congruent to WY because of the reflexive property. So we would say WY is congruent to WY because of the reflexive property, and then W is the included angle in both of them, so we would be able to use side angle side. So this is our beginning of setting up a 2-column proof, and on these two, then all we would have is we would just have our statements and our reasons, and then we would just go through, list out all the things that we know, the reasons why, and hopefully we get down to the end. So good luck with this. Again, stay positive with it. It's going to feel a little different because there's not a whole lot of algebra math like we did with proving and using the algebraic proofs. Okay, there's going to be a lot less numbers to go along with what we're doing here. So stay positive, keep an open mind.